Hey everyone, this is Dr. Walker. This is video 206 and it is called the Superposition Principle. So we just learned about Coulomb's law and how there's a force between charges. In this video, we want to learn about the vector nature of this force, and to help us with the fact that forces are vectors, we're going to use the superposition principle to add up our forces. So basically all we're saying is that if there is more than one force acting on a charge, and you want to know what is the net force acting on that charge, then you're going to have to add those forces using vectors, so using the vector sum. So basically it goes back to adding vectors like we learned in Physics 1. You can see in this picture, we're not going to go over this exact example, it's just a visual, but we have a charge Q3 here, a charge Q1, and a charge Q2. All three charges are experiencing forces, but we're just focused on the forces acting on Q3. So acting on Q3, we have a force F13 due to charge 1 acting on number 3. So there are two positive charges, so they're going to repel each other. So that's this force right here, repelling force between 1 and 3. And then we have force 2-3, which is the force from 2 acting on number 3. A negative and a positive charge are opposite charges and they're going to attract. So we have charge 3 being attracted to charge 2, so there's an arrow to the left. So how do we add these two forces? We have to use vectors, and this requires finding the x and y components of each vector. As you can see here, we have found the x and the y component of F13, and it's going to require separating the x and y components in order to add them. So we are going to do a guided example of this in the video that is linked to this lecture. The last thing I want to do in this video is go over a conceptual example, and to answer it, just keep in mind that you have to add forces using the vector addition rules that you learn about in Physics 1. So let's take a look at this example. It says, which is the direction of the net force on the charge at the top? So we have three forces. And again, pause the video to really think about this. The first thing that you want to do is you want to draw each force that is acting on this one. These four arrows here are not the forces acting on this charge. These are the four possible answer choices. So if you want, you can just redraw this picture. Ignore the answer choices for now. So we have a plus and a minus and a plus. And what you're going to do is you're going to draw the forces acting on this top charge due to the other two. So pause the video and try that for a second. And let's go ahead and do it together. These two positive charges will repel each other, so you can imagine a straight line in between them, and then that repelling force is going to be along that line, but it's going to be repelled, so it goes to the right and up. And then the positive and the negative charges will be attracted to each other because they're opposite charges. So you can again imagine the line joining the two charges, and then the force is going to be along that line. So we have two forces acting on this top charge. Now let's just for practice, let's just go ahead and label these charges. Let's call it Q1, Q2, and Q3. So this force up here would be the force from charge 2 acting on charge 1. And then this force down here would be the force from charge 3 acting on charge 1, just to kind of get practice with the notation. So now the question is, well, what is the net force if you have one force up and to the right and one force down and to the right? Do you remember your vector addition tricks that you learned that you can do without any numbers? Do you remember the tip to tail method? Let's give it a shot. So if we're trying to add these two vectors, we can draw vector 2, 1 here, and hopefully I'm not changing the direction too much. And then at the tip of vector 2, 1, we're going to put vector 3, 1. Vector 3, 1 is going down this way. So the tip-to-tail method that we learned in Physics 1, it told us if we add them tip to tail, then the resultant or the net force is going to be from where you start to where you end. So this would be the net force. So the net force is to the right, so the answer is D. You could have also thought about this by thinking, well, we know that the actual amount of the force is the same because all of these charges are the same, right? It's just 1 plus or 1 minus is still the same Q, right? The charges all have the same magnitude. So the force is going to be the same number, right? The distance between is the same. Again, you just have to assume that from the picture. So if the force is the same, the magnitude of the force, then the up and down components are going to cancel each other out, but they both have a component to the right, so that component is going to add. So this was a quick example on vector addition conceptually without numbers, just to remember that the vector nature of forces is really important. And we're going to have another video where we do a guided example dealing with numbers to figure out what is the resultant force on a charge when there are more than one charge nearby.